Hello students, welcome back to the another session of our data structure journey. Today we are going to learn what are the different type of searching techniques. Also we cover one by one searching techniques. So there are basically two type of searching techniques is available in the data structures. First one is the linear search or sequential search. Second category we call as the binary search. So let's start the first searching algorithm of the data structure, that is the linear search algorithm. It also called as the sequential search, which involves the comparing of the data sequentially with the element in the list. So first it begins with the comparing the data with the first element. Here what is our objective list? A list consists of number of elements and we are going to search the value whether the sub element is present inside the list or not. So for that we have to begin by comparing the searching element with the first the data. If the value does not match with the first element of the list, then we go for the second element, third element, so on until we are not reach the value or either end of the list, because there are two possibilities whether the data is present or data is not present. So we have to search till end. So what is the algorithm for the linear search? So this is the algorithm for the linear search. So here what happened, initialization, we make the flag as a zero, means we assume that the element is not present. For the element present or not, searching element present or not, we make a variable that is the flag. Initialization 0 means it is false, means the element is not present inside the list. That's why we make the flag as a 0. Then we set the value equal to 0 because we have to traverse the entire list to search an element. So as we are going to store the element, that is the n number of elements, so we have to search from 0 to n minus 1. Reason is that we are storing the data in a array right now. So we have to repeat the step while I is less than equal to n. If the index value of I value is equal to the searching element, then we have to make the flag as a 1, means it represent the element is already present inside the list. Then we have to find out the position. Position is equal to the I plus 1. Why? Reason is that I is initially starting from 0. That's why whenever we have to find out which position it is present, we have to make the I plus 1. Then we have to print the value and we have to go to the step 6. So what is the step 6? Exit, because we are already got the value, no need to traverse the entire list. So this process, then what happened? I equal to I plus 1 means each and every iteration we have to traverse one by one. Then what happened? Last, we have to make check whether flag equal to 0 or not. If the flag equal to 0 means we conclude that the element is not present, we are already reached the end of the list, and then we have to print that value is not present inside the array or the list of elements. Then we have to exit. So let's take an example. This is a 0, that is the 20, 10. So these are the elements. So how indexing is going on? 0, 1, 2, 3, 4, 5, 6, 7. Then how many number of elements? N is here 8. 1, 2, 3, 4, 5, 6, 7, 8. So indexing starting from 0 to n minus 1. That's why here I is equal to less than equal to n. If so, now what happened? It is equal to n minus 1. Then what happened? For example, we have to search the value, that is the key value we are searching, that is 35. So what is the initialization value? 0. So we make the compare with this value. 20, no matching, that will go to the second element. Then it will go to the third element. Now it will go to this element. Now, so in this location, we found the element. But what happened? What is the I value? I value is 3. But what is the position? 0, 1, 2, 3, 4. That's why we have to make the flag equal to 1. And we have to make the position equal to I plus 1. 3 plus 1 means 4. So now the element is present which location? Which location or which position it is? It is the position of 4 positions. So this is the way the linear search algorithm is perform its operation. So let us go back to the our programming point of view. We have to do the program also. So program is our implement the linear search algorithm. So we are included two header file, input output header file, as well as for the clear screen and get ch function. For that we are using the Cuneo. So let's start the main function, integer main. So here the list of element we are going to store in a array name as A. For example, the size I make as a 20. So maximum element it can store the 20. And we also require n variable to store the size of array. Traversing all the elements, we require another variable, that is the I. So for example, we want the end user to the enter the size. So please enter the size of array. Or we can say it is a list of element we want to store inside that array. So we have to scanf, means we have to read the value and store which variable. We have to store in the n variable. So n variable used to store. Then we have to enter the value. So for that we have to use for I equal to 0, I less than equal to n minus 1, I plus plus. So this much iteration we require to read the value for the array. So here we can write down printf enter the data into array. Then scanf AI, we have to store in this address. So after that, what happened? Our insertion is over. Then if we want to print what are the elements, we can printf. So we can use the printf. The elements of array. We just want to know, we want to print what are the elements present inside the array. That's why we go for another for loop. So for I equal to 0, I less than equal to n minus 1, I plus plus. Then we print the value. Printf %d, then one tab, because we want each and every element should be separated by the tab. So it will print the element present inside the array. After that, we have to search the element. So what for the searching, we have to use the printf new line, enter the element for searching. So whatever we enter, for example, we store inside the variable, that is the key. So we require another variable of integer, that is the key. Key means we want to search the element. So scanf %d percent key. So here what happened? First we have to assume that the element is not present. For that we make a variable, that is the flag, and we store the value as a 0. Flag equal to 0. So we initialize the flag equal to 0 means we assume that the element is not present. As it is a linear search means one by one element we have to search. So traversing starting from 0 to end of the list. So 0 to, so I equal to 0 to I less than equal to n minus 1 I plus plus. So here what happened? We have to first check whether the element is present or not. So for that, what we have to do? We have to make the if condition. If ai is equal to our searching element, then what we have to make? First, we have to make the flag equal to 1 because the element is present. Then we have to print the value. Printf new line %d percent means number is present. So we make the present inside list. So we just make that the element is present. Which element? That is the key. Then we have to break because once we got the value, no need to traverse the entire list. That's why we use the break statement. After the for loop, we check whether the element is not present. So what is the condition? If flag equal to 0, it means that the element is not present. So we write down printf new line %d is not present inside list. Which value? It will print the key value. So we have to make the semicolon. Then return 0 because we make the main function as a integer. So we have to return the 0. Let's compile the program. No error. So first it asks us what is the RS size. For example, I enter the 5. So it asks the enter the value 10, then 15, then 9, then 20, then 90. So after that, it print that the element of array because here what happened? For example, I enter the searching element is 100. So here what happened? It will be come back. So we want it should be wait for one character we should enter. So now let us compile and run the program once again. So I enter the size is 10 means I have to enter the value 10 times. So this is the element of the array. Now we have to enter the searching element. For example, I enter the searching 32. So output will be displayed that is the 32 is present inside the list. But it will not print the which position because only we in the program we write down only the 32. So let us add the position. So present inside list at position. So what is the position? Indexing starting from here we are start searching from 0, indexing 0, but position is 1. So whenever we reach the value at that time, I means the position is I plus 1. So we make the I plus 1 here. Let us compile the run program once again. So for example, size is so this is the array element. For example, I enter the searching element is 14. Is present at position, but it will not display. Why? Because here we are not mention the percentage. So these are the silly mistake we did in this program. I just want to explain this thing because these are the silly mistake we did and we thought that why we are not getting the correct result. Now, for example, again I enter the 40 position 4. Now we got the correct result or not? Let us we do another run to for element is not present inside the list. 99 is not present inside the list. So our program is executing correctly. So what is the time complexity of the linear search? For the best case, the order it is order of one. Why? Because it occurs when the searching element is the first element. Means there are n number of elements and we are going to search an element. But fortunately, the element is present in the first location. At that time, it is our best case and the time complexity is order of one. Average case, that is the order of n. It occurs when the searching element is present inside the middle or we don't know what is the exact location. That time the average case will occur and it will be order of n because n is the number of element present inside the list. Next one is the worst case. So it occurs when the searching element present inside the last location of the list and we have to traverse each and every element present inside the list to end of the because the element is present in the last location, that's why we have to move to the last location. Next one, what is the advantage of linear search? It is very easy to understand and implement because sequentially we have to traverse to end of the list. It can be used for both sorted as well as the unsorted because whenever you go for linear search or sequential search, it is immaterial for us whether the elements are sorted or not. Any order we can go for search and we will check the value is present inside it or not. It can be easily changes means when the data is changes frequently. For example, we take a case of the data set where the elements are changes rapidly. Whenever changes is rapidly and we are using the linear search, it is 100% chances to get the element present or not. So next one, can be applied with the array, linked list or any data structure without any changes. Means we don't have to change it. We can use the algorithm directly. So next one, what is the disadvantage? Disadvantage means its time complexity order of n. For that, it becomes very slow and inefficient for the big data set. Whenever our list of element is too large, so at that time, it is not recommended that we should go for the linear search. When our data set is already sorted, the linear search cannot able to take the advantage. This is the main drawback of the linear search because it has to traverse unnecessary to the end of the list by comparing each and every element. It is very slow compared to the advanced because there are so many advanced searching techniques available that is the we can take the binary searching. So compared to with that, it is very slow. Thanks for watching the video. Please subscribe the channel, like the channel as well as the share the channel. Thank you so much.